All right, for my video for control systems, I decided to go with the block diagram reduction. It's a topic that I'm pretty familiar with, and I feel like it's pretty useful for most students to get a further understanding of it. I feel like I can describe it pretty well, enough to further the understanding of some and help with some assignments, whether those be labs or homeworks. So what are block diagrams? A block diagram is a visual representation of a control system depicting each element as a box or a block and their interconnections as lines. These diagrams illustrate how signals flow through the system and how different components interact with each other. Essentially, a block diagram is a graphical model that helps understand and analyze control systems. It can be big or small. Each component is represented by a different block. So block diagrams are reduced to simplify complex control systems. It makes them easier to analyze and understand. By combining blocks and eliminating unnecessary connections, the overall system's behavior becomes more transparent, and it helps us determine the transfer function in analyzing the system's performance as a whole. So before we tackle the problem, we have to look at a couple of the rules. Whether the transfer function is defined as g over 1 plus g times h, or whether it's defined as g over 1 minus g times h, it is given by the sign where h of s comes back to the system in the loop. So you can see the difference between the two. We have a minus here, we have a positive here. And then I drew a couple arrows that kind of help describe that. Those are shown here. So it depends where the h of s is fed back to the system. There are a couple more simple rules to learn before we do a practice problem. One of these rules is that blocks in series get multiplied together to become one, while blocks in parallel are added together to become one. And then next we have one of the problems we did in class. All right, so this is one of the problems that we did in class. I think that it covers just about every rule for simplifying the block diagram. Our goal is to simplify this block diagram to find the transfer function T of S, which is defined by C of S over R of S. The first step when given any problem from the textbook is to draw it out by hand, which lets us work on it and to better understand what's happening as a whole. It really helps our understanding to draw it out. And then next I use a highlighter to show three different areas of interest for this problem. The first is a block that's by itself, the 1 over s squared. We can sort of just keep that to the side until later. The next system to deal with is the one highlighted in purple. We have two blocks here, one being 50 over the quantity of s plus 1, and the second being 2 over s. And then we can apply some of the rules here. H of s, which is 2 over s in this instance, is going back into the system with a negative sign. This means that the formula that we use is g over 1 plus h times g. The math for this is drawn out underneath the block diagram. I have it where we get those two blocks simplified as 50s over the quantity of s squared plus s plus 100. Lastly, we have the blue circle blocks. Notice how these are in parallel. So if we refer back to the previous rules, this is simplified as s minus 2. All right, a useful next step is to redraw the block diagram with all the simplifications that we have made thus far. The colors are the same as circled in the previous slide. Really helps with some understanding if you can color code it too, whether those be different pens or if you have softwares that do this too. Now, if you look at all three of these blocks are in series, we think back to one of those first rules where every block in series gets multiplied with each other. And I have that shown underneath the blocks as 50s times s minus 2 over the quantity of s squared plus times s to the s cubed and then plus s plus 100. Finally, we are left with the final block diagram, which is shown here, which is 50 times s minus 2 all over s cubed plus s squared plus 150s minus 100. So overall, in this video, we learned how to simplify block diagrams and obtain a transfer function from a closed loop system. Very useful topic, comes in handy on tests, quizzes, labs, and in the real world as well.